I started the problem with the director section by declaring our known and unknown variables. So we know the mass that's hanging between the two cables, and then we know the lengths of each of the cables that are holding up the mass. We also know the accompanying angle theta in between the ceiling and the actual tension ropes. So we're actually solving for the tension in each of the cables, and one of the unknowns is the height between the mass and the ceiling, and then also what I call theta subset 2, which is basically just the complement of theta. And then the equations that we'll be using are F equals mg, which is the force of gravity times mass to get you the Fy component. And then tension force, which is basically just tension, and then we're going to multiply by whatever the sine theta is, or the angle. So we're gonna factor in the angle, and the reason we just use sine is because the x component, or cosine, is gonna cancel out as the x components are holding it in both directions, and it's mostly y component going down. And so once we have plugged into our equation, we can say that the force tension equals the force of gravity. So mg is equal to t sine theta plus t sine theta, because there's two cables, which is 2t sine theta. And then if you isolate t, you're going to divide both sides by 2 sine theta, and you're going to get mg over 2 sine theta. For the execute section, we're going to plug in for sine theta. And sine theta is, as we know, is equal to the y component over the hypotenuse, so h over L. So it's going to be t equals mg over 2 times h over L. And then for the skeptic section, we know that the answer is in force, which is newtons, or kilograms times meters per second squared. And the bottom part is just a number, but the top part is mass times gravity, which is going to be in kilograms times meters per second squared. So our units check out. I said the two ways to check it are plug in numbers, and if the double tension is equal to the mass of gravity, then you've done your numbers correctly. I also said that you can see if both the tension forces combined, cut in half, are equal to 1. And then for the behaviors, I said that if you make the angle bigger, then the force of tension gets bigger, and then if the mass is bigger, then so is the force. So that's what I did.